Imagine a time before time when the universe was a vast canvas of darkness, punctuated by the faint glow of distant stars. In a quiet corner of the Milky Way, some 4.6 billion years ago, a giant molecular cloud stirred from its slumber. This wasn't just any cloud, it was a cosmic cradle woven from hydrogen, helium, and the ashes of ancient stars that had long since exploded in spectacular supernova. Their remnants, carbon, oxygen, iron, floated like stardust, waiting for a spark to ignite creation. Then it happened. A shock wave from a nearby supernova rippled through the cloud, compressing its gases until gravity seized control. Dense clumps began to collapse, spinning faster as they shrank, like a figure skater pulling in their arms. At the heart of one such clump, pressure and temperature soared until a protostar flickered into existence, shrouded in dust and glowing faintly in infrared. Jets of hot plasma erupted from its poles, carving paths through the cosmic fog. Within a few million years, the core reached a blistering 10 million degrees Celsius, and hydrogen nuclei began fusing into helium. In that moment, the sun was born, a thermonuclear beacon igniting the center of a newborn solar system. This was no mere spark. The sun's birth was a cosmic symphony, its light scattering the remaining gas and leaving behind a disk where planets would form. Earth, our fragile home, would emerge from this chaos, orbiting a star destined to shine for billions of years. But even as the sun entered its stable main sequence phase, a clock began ticking, a countdown to its fiery end. This is the story of our star, a tale of creation, power, and an inevitable reckoning that will reshape our solar system. Buckle up, because this journey spans billions of years, and it's going to be a wild ride. To understand the sun's life and its eventual death, we must dive into its fiery core, a place where the laws of physics dance on the edge of the impossible. At the sun's center, temperatures soar to 15 million degrees Celsius, and pressure is so immense that hydrogen atoms are stripped bare, forced into a cosmic waltz. Here, in this thermonuclear furnace, the sun's power is born through the proton-proton chain, a sequence of nuclear reactions that transforms matter into energy. Picture two protons hurtling through the chaos of the core, their positive charges repelling each other like magnets. Classical physics says they should never fuse. The electrostatic barrier is too great, yet the sun shines. Why? Enter quantum mechanics, the strange realm where particles behave like waves. Through a phenomenon called quantum tunneling, protons can slip through this barrier, as if finding a hidden door. It's rare. Only 1 in 10 to the 28th power collision succeeds. But when it does, magic happens. Two protons merge, one transforming into a neutron via the weak nuclear force, forming a deuteron. This reaction releases a positron, which annihilates with an electron in a burst of gamma radiation, and a neutrino, a ghostly particle that escapes the sun at nearly the speed of light. Billions of these neutrinos pass through you every second, unnoticed. The deuteron then collides with another proton, forming helium-3 and releasing more gamma rays. Finally, two helium-3 nuclei fuse into helium-4, ejecting two protons to start the cycle anew. The result? 4 protons become one helium-4 nucleus, with a tiny fraction of mass converted into energy, as Einstein's E equals mc squared dictates. This process is staggering in scale. Every second, the sun fuses 600 million tons of hydrogen, releasing energy equivalent to billions of nuclear bombs. Yet, for any single proton, fusion is a rare event, happening perhaps once in billions of years. The sun's sheer size, containing enough hydrogen to sustain this for 10 billion years, ensures its steady glow. But this energy doesn't escape easily. Gamma rays born in the core embark on an epic journey, zigzagging through the dense radiative zone for up to 170,000 years, absorbed and re-emitted countless times. By the time they reach the convective zone, a turbulent ocean of plasma, they've transformed into visible light, ready to race across space. The sun isn't a serene orb of light. Its surface is a battleground of magnetic forces, where colossal energies clash in spectacular displays. The photosphere, the sun's visible layer, is a thin veil of gas, only 400 kilometers thick, glowing at 5,500 degrees Celsius. Through telescopes, we see granules, continent-sized cells of hot plasma rising and sinking in a cosmic boil. Each granule, roughly 1,000 kilometers across, lasts mere minutes before new ones take their place. But the photosphere hides a deeper secret, the tachocline, a shear layer where the sun's rotation shifts dramatically. Below, the radiative zone rotates like a solid sphere every 27 days. Above, the convective zone spins faster at the equator, 24 days, and slower at the poles, 34 days. This mismatch generates the sun's magnetic dynamo, twisting plasma into magnetic loops that drive everything from sunspots to solar flares. Sunspots, dark blemishes on the photosphere, mark regions where intense magnetic fields, thousands of times stronger than Earth's, suppress convection, cooling the surface to 3,500 degrees Celsius. These spots, often larger than Earth, appear in pairs of opposite magnetic polarity, connected by loops of plasma. Surrounding them are bright faculae, where magnetic fields enhance heat flow, making the sun slightly brighter during peak activity. Above the photosphere lies the chromosphere, a ruby-red layer visible during solar eclipses. Here, temperatures mysteriously rise with height, from 4,000 to 8,000 degrees Celsius, defying intuition. Spicules, plasma jets shooting 10,000 kilometers upward, erupt in their millions, shaping a dynamic web of supergranules. Beyond, the corona, a pearly crown stretching millions of kilometers, glows at over 1,000,000 degrees, its heat a puzzle science has yet to fully solve. From this halo, the solar wind carries charged particles across the solar system, bathing planets in the sun's influence. The sun's magnetic fields are restless, twisting and snapping in violent outbursts. Solar flares, explosive releases of energy, occur when magnetic loops reconnect, heating plasma to tens of millions of degrees in seconds. These flares unleash X-rays, ultraviolet radiation, and particle storms, with the most powerful equivalent to 1 billion megaton bombs. Coronal mass ejections, CMEs, meanwhile, hurl billions of tons of plasma into space at speeds up to 3,000 kilometers per second. When a CME strikes Earth, it can spark geomagnetic storms. The aurora, dazzling curtains of green, red, and purple, lights up polar skies as charged particles collide with the atmosphere. But these storms aren't always benign. In 1989, a solar storm blacked out Quebec's power grid for 12 hours, with auroras visible as far south as Florida. The 1859 Carrington event, the strongest recorded, sparked telegraph wires and ignited fires. A similar event today could cripple power grids, satellites, and communications, costing trillions. In July 2012, a Carrington-scale CME narrowly missed Earth, a reminder of our vulnerability. The sun's activity follows an 11-year cycle, with sunspot numbers peaking at solar maximum and dwindling at minimum. During solar maximum, flares and CMES surge, increasing space weather risks. The current cycle, Solar Cycle 25, began in 2019 and is expected to peak in mid-2025, with sunspot counts already exceeding predictions, according to NOAA's Space Weather Prediction Center, September 2025 data. This cycle's intensity underscores the need for vigilant monitoring, as even a single storm could disrupt our tech-dependent world. The sun doesn't sit still. It orbits the Milky Way's center every 230 million years, weaving through a galaxy teeming with stars. Occasionally, a star passes close, within a few light years, tugging at the solar system's delicate balance. The Oort cloud, a distant shell of comets, feels these nudges most, potentially sending comets inward. But what if a star comes closer? A 2025 study in the Astrophysical Journal simulated the solar system's fate over 5 billion years, factoring in stellar flybys. The results are sobering. A star passing within 100 astronomical units, twice Pluto's orbit, could destabilize planetary orbits. Mercury, already prone to chaos, faces an 80% higher chance of colliding with Venus or the sun. Earth has a 0.2% chance of being ejected or crashing, a 1 in 500 risk over 5 billion years. Pluto, surprisingly, has a 5% chance of ejection. These odds, while small, remind us that our solar system is not an isolated fortress, but a fragile clockwork in a cosmic sea. As we marvel at the sun's grand cycles and cosmic dance, recent discoveries have revealed its secrets on the smallest scales, painting a picture of a star more intricate than we ever imagined. In 2025, the Daniel K. Inouye Solar Telescope in Hawaii, the largest of its kind, captured images of unprecedented clarity, zooming in on the sun's photosphere to reveal magnetic structures as small as 12 to 30 kilometers wide, barely the length of a city block on a star spanning 1.4 million kilometers. These These ultrafine magnetic striations, like delicate threads woven into the edges of solar granules, are a revelation. They appear as alternating light and dark bands, tracing the boundaries where hot plasma rises and cooler plasma sinks. Each striation is a magnetic curtain, a sheet-like field that modulates light as it passes through, creating a subtle fingerprint of the sun's magnetic complexity. These tiny structures are more than a curiosity. They could hold the key to unraveling some of the sun's greatest mysteries. Scientists hypothesize that these micromagnetic fields play a role in heating the corona to its blistering million-degree temperatures, a phenomenon that defies the cooler photosphere below. The interplay of these fields might also trigger larger eruptions like flares or CMES by channeling energy through the solar atmosphere. Imagine a vast network of these magnetic threads, each one a spark in a cosmic web, collectively influencing the sun's behavior. The Inouye telescope's observations, detailed in a 2025 Solar Physics Journal article, suggest that these structures could improve space weather forecasting, helping us predict when the sun's tantrums might threaten Earth's technological infrastructure. This discovery reminds us that even in the vastness of a star, the smallest details can have universe-altering consequences, connecting the microscopic to the cosmic in a way that sparks both wonder and urgency. Beyond its fiery core and restless surface, the sun pulses with a rhythm that shapes its behavior and our world, a cadence of cosmic seasons known as the solar cycle. Every 11 years, the sun oscillates between periods of intense activity and relative calm, marked by the rise and fall of sunspots. At solar maximum, hundreds of sunspots pepper the photosphere, each a hotspot of magnetic turmoil spawning flares and CMEs that ripple across the solar system. At solar minimum, the sun's face may appear pristine for weeks, its magnetic field subdued. This 11-year cycle, first identified by Samuel Heinrich Schwabe in the 1840s, is driven by the sun's magnetic dynamo rooted in the tachocline's shear. Every 22 years, the sun's magnetic field completes a full cycle, flipping its north and south poles twice to return to its original orientation, a phenomenon called the Hale cycle. This rhythmic dance, visualized in the butterfly diagram where sunspots migrate from mid-latitudes to the equator, is as predictable as Earth's seasons, yet varies in intensity, with cycles ranging from 9 to 14 years. Historical anomalies like the Maunder minimum of the late 17th century saw sunspots nearly vanish for 70 years, coinciding with the Little Ice Age, hinting at the sun's influence on Earth's climate. Today, as solar cycle 25 peaks in 2025 with higher than expected sunspot counts, NOAA, September 2025, we're reminded of the sun's power to shape our technological world. During maximum, the sun's slight brightening, due to faculae outshining sunspots, adds 0.1% to its luminosity, while its magnetic storms threaten satellites, power grids, and astronauts. Conversely, at minimum, a weaker solar wind allows more cosmic rays to reach Earth, posing risks to high-altitude flights and space missions. This cycle is a cosmic heartbeat, a reminder that the sun is not a static beacon, but a dynamic force, its rhythms echoing through the solar system and into our lives, urging us to adapt and prepare for its unpredictable moods. The sun's story is not confined to its own system. It's a traveler in a vast galactic sea, orbiting the Milky Way's center in a journey that spans 230 million years. As it weaves through the galaxy, oscillating above and below the galactic plane, the sun encounters other stars, each passage a potential disruptor of our solar system's delicate balance. Most encounters are distant, measured in light years, their gravitational tugs barely felt except in the far reaches of the Oort cloud, where comets may be nudged inward to streak across our skies. But closer flybys, within 100 astronomical units, roughly twice Pluto's orbit, are cosmic game changers. A 2025 study in the Astrophysical Journal ran thousands of simulations, revealing that such encounters, with a 5% chance over 5 billion years, could unravel the solar system's clockwork. Mercury's orbit, already wobbly from internal dynamics, faces an 80% higher risk of colliding with Venus or the Sun. Earth, our stable home, carries a 0.2% chance of being ejected into the interstellar void or crashing into another planet, a sobering one in 500 odds. Pluto, perched on the solar system's edge, has a 5% chance of being flung out entirely. These disruptions could cascade, with a single close encounter triggering multiple planetary losses within 1 to 2 billion years, far sooner than isolated models predict. The Oort cloud, a trillion comets encircling our system, would almost certainly be stirred, potentially bombarding the inner planets with icy missiles. This galactic journey transforms the sun from a solitary star into a participant in a cosmic ballet, where every step through the Milky Way's crowded stellar fields carries the risk of chaos. Yet it's also a testament to the resilience of our system, which has endured countless passages over billions of years. Its planets holding their orbits against the odds, a fragile yet enduring dance under the sun's watchful glow. Delving deeper into the sun's nature, we uncover a tapestry of magnetic forces that weave through its layers, shaping its behavior in ways both subtle and explosive. The tachocline's shear, where rotation shifts from uniform to differential, is the crucible of the sun's magnetic dynamo, but its influence extends far beyond. Magnetic fields thread through the photosphere, chromosphere, and corona, creating a dynamic network that governs everything from sunspots to the solar wind. In 2025, the Daniel K. Inouye Solar Telescope revealed magnetic striations as small as 12 kilometers, delicate curtains of magnetism rippling along granule edges, modulating light in a dance of bright and dark threads. These microstructures, detailed in Solar Physics 2025, may hold clues to the corona's million-degree mystery, where temperatures soar inexplicably above the cooler photosphere. Scientists theorize that these tiny fields, collectively spanning the sun's surface, could channel energy upward, heating the corona or sparking flares and CMEs. Larger magnetic structures, like the loops connecting sunspot pairs, arc thousands of kilometers into the corona, trapping plasma in glowing arches visible during eclipses. These loops, born in the tachocline's dynamo, twist and snap in magnetic reconnection events, releasing energy that can dwarf Earth's mightiest storms. The sun's magnetic field also drives the solar wind, a stream of charged particles that sculpts the heliosphere, a protective bubble shielding our system from galactic cosmic rays. Yet this field is ever-changing, flipping polarity every 11 years, reshaping the sun's atmosphere and influencing space weather. Understanding this magnetic tapestry is crucial, not just for unraveling the sun's inner workings, but for protecting our world from its outbursts. As we refine our models with data from observatories like Inouye, we edge closer to predicting when the sun's magnetic moods might unleash chaos, a pursuit that blends awe for its complexity with the practical need to safeguard our technological future. The sun's main sequence phase, stable for 4.6 billion years, will end in about 5 billion more. When its core exhausts hydrogen, gravity will compress it, igniting fusion in a surrounding shell. This extra energy will swell the sun into a red giant, its radius ballooning to 1 astronomical unit. Mercury and Venus will be engulfed, their surfaces liquefied. Earth's fate hangs in the balance. Some models suggest it may escape, orbiting within the sun's outer layers, but friction could drag it inward to vaporize. Long before engulfment, the sun's increasing brightness will boil Earth's oceans and strip its atmosphere, rendering it a barren husk. After a brief helium flash ignites carbon fusion, the sun will burn helium for 100 million years, shrinking slightly. When helium runs out, unable to fuse carbon, the sun will swell again, shedding 30% of its mass in powerful stellar winds. Its core, now a white dwarf the size of Earth, will ionize the ejected gas, forming a glowing planetary nebula, a final radiant farewell. As the sun approaches its twilight, its story becomes a mirror for our own existence, a reminder of the fleeting yet profound nature of life in the universe. Every photon that warms our skin, every blade of grass bathed in golden light, owes its existence to the sun's tireless fusion, a process that has sustained life for billions of years. Yet this same star, our nurturing parent, will one day turn executioner, consuming its planetary children in a fiery embrace. This duality, creator and destroyer, echoes the cycles of the cosmos itself, where stars are born from chaos and return to it, leaving behind nebulae that seed new generations. The sun's planetary nebula, a shimmering shell of gas glowing with ultraviolet light, will drift through the galaxy, perhaps sparking the formation of new stars and worlds. In this way, the sun's death is not an end, but a transformation, a passing of the torch to future cosmic stories yet unwritten. The inevitability of the sun's fate invites invites us to reflect on our place in this grand narrative. We are, in every sense, children of the stars, our bodies forged from elements born in ancient stellar cores, our lives sustained by a star that has shone faithfully for eons. Yet, the sun's story is a call to action, urging us to cherish the fleeting window of habitability Earth enjoys. In 2025, as humanity pushes the boundaries of space exploration, missions to Mars, lunar bases, and telescopes peering into the cosmos, we stand at a crossroads. Will we harness the sun's energy to propel us to new worlds, or will we remain tethered to a planet destined to burn? The Sun Saga challenges us to dream bigger, to innovate, to explore, and to preserve the fragile beauty of our world while it lasts. It's a story that humbles us, reminding us that our time under the sun is brief, but our potential to leave a lasting mark on the universe is boundless. The sun's influence extends far beyond its physical processes, weaving itself into the very fabric of life on Earth in a symbiotic dance that has shaped the planet's history and destiny. From the moment photosynthetic organisms harnessed sunlight to convert carbon dioxide into oxygen billions of years ago, the sun became the engine of life, driving the evolution of complex ecosystems. Every leaf that unfurls, every wave that crashes, every breath we take is powered by the sun's radiant energy, captured and transformed through intricate biological and geological cycles. The sun's steady output during its main sequence phase has provided a stable climate window, allowing life to flourish from single-celled microbes to the sprawling civilizations of today. Yet this relationship is not without its tensions. Solar variability, even within the narrow 0.1% fluctuation of the solar cycle, can influence Earth's climate, as seen during the Maunder minimum's correlation with the Little Ice Age. In 2025, as solar cycle 25 peaks, scientists at NASA and the European Space Agency note that subtle changes in solar irradiance could amplify climate patterns, potentially exacerbating extreme weather events already intensified by human activity. The sun's magnetic storms, while painting auroras across the skies, also pose risks to modern life, threatening satellites that guide our navigation, power grids that light our cities, and communication networks that connect our world. This interplay is a delicate balance, where the sun's nurturing light sustains us, yet its occasional fury reminds us of our vulnerability. As we stand on the cusp of interplanetary exploration, with plans for lunar habitats and Martian colonies by 2030, per SpaceX and NASA timelines, the sun's role as both provider and peril becomes ever more critical. Harnessing solar energy through advanced photovoltaic technologies, like those deployed in 2025's International Solar Alliance initiatives, could power our leap to the stars, but only if we learn to navigate the sun's moods. This cosmic dance with life is a testament to the sun's dual nature, a beacon of hope and a force to be respected, urging us to adapt, innovate, and deepen our connection to the star that gave us life. Beyond its physical presence, the sun has burned brightly in the human imagination, serving as a muse for art, myth, and science across millennia. From the ancient Egyptians who revered Ra, the sun god, as the source of all creation, to the Incan Inti, whose golden rays symbolize divine power, the sun has been a universal emblem of life, hope, and eternity. In 2025, as we marvel at high-resolution images from the Inouye Solar Telescope, this ancient reverence finds new expression in our quest to understand the star's mysteries. The sun's cycles have inspired calendars, festivals, and rituals. Think of Stonehenge's solstice alignments or the global celebrations of equinoxes that persist today. Its light has painted masterpieces, from Van Gogh's swirling sunflowers to the golden hues of Renaissance frescoes, capturing its warmth and vitality. Scientifically, the sun has been a catalyst for discovery, from Galileo's 17th century sunspot sketches to the 2025 breakthroughs in solar magnetic mapping. Yet its cultural impact is not without shadow. Myths of solar wrath, like the Norse tale of Skirl chasing the sun to herald Ragnarok, echo our modern fears of solar storms disrupting our digital age. The 1859 Carrington event, which awed 19th century observers with auroras while sparking telegraph fires, underscores this duality, a star that inspires awe and demands caution. Today, as we share images of solar flares on social media and debate climate impacts at COP30, scheduled for November 2025 in Brazil, the sun remains a cultural touchstone, uniting humanity in wonder and urgency. Its story, told through ancient myths and cutting-edge science, reminds us that we are not just observers, but participants in a cosmic narrative, compelled to honor the sun's legacy by protecting our planet and reaching for the stars. As we gaze into the sun's distant future, its inevitable transformation into a red giant casts long shadows over humanity's path, challenging us to confront our place in the cosmos with both humility and ambition. In 5 billion years, when the sun swells to engulf Mercury and Venus, Earth may face a fiery end, its oceans boiled away and atmosphere stripped long before. Yet this distant fate sharpens our focus on the present, where humanity's response to the sun's power is already shaping our future. In 2025, global efforts to harness solar energy are accelerating, with the International Energy Agency reporting that solar power accounts for 20% of global electricity, driven by innovations in perovskite solar cells and orbital solar farms proposed by China's space program. These advancements, coupled with AI-driven space weather forecasting, pioneered by NOAA and ESA, aim to mitigate the sun's disruptive outbursts while tapping its boundless energy. But the sun's future also sparks existential questions. Will humanity remain tethered to Earth, vulnerable to its star's whims, or will we become a multi-planetary species, as envisioned by initiatives like the Artemis program, targeting lunar bases by 2028? The sun's life cycle is a cosmic deadline, urging us to colonize Mars, mine asteroids, or even venture to exoplanets orbiting younger stars. Projects like Breakthrough Starshot, aiming to send probes to Alpha Centauri by 2050, reflect this ambition. Yet closer to home, the sun's increasing brightness over the next billion years, projected to rise 10% per billion years, threatens Earth's habitability, potentially triggering mass migrations or geoengineering efforts to cool the planet. This future demands not just technological prowess, but ethical foresight as we balance exploration with stewardship of Earth's fragile ecosystems. The sun's saga, with its promise of destruction and creation, is a clarion call to act now, to innovate, to unite, and to dream of a future where humanity thrives under new suns, carrying the legacy of our star into the cosmic unknown. The sun's story is our story. Every atom in our bodies was forged in stellar furnaces. Every ray of sunlight a gift from a star that has shone for billions of years. As we stand beneath its glow, we're linked to the universe's past and future. The sun's eventual demise is a reminder of our place in the cosmos. Temporary, yet wondrous. Its light has nurtured life, inspired art, and powered civilizations. And as long as it shines, we have a chance to explore, create, and dream. What do you think of this cosmic saga? Drop a comment below to share your thoughts. Does the sun's future awe or unsettle you? Hit that like button if this journey through the stars sparked your curiosity, and subscribe for more tales from the universe. Let's keep exploring the cosmos together.